So an important application of logarithms in geology is the Richter scale for measuring the magnitudes of earthquakes. And it's based on the following formula. It looks scary at first, but it's actually pretty interesting. So M, which is eventually going to be the magnitude of an earthquake. And you've probably often heard this on the news, like, oh, it's this place there was an earthquake with magnitude 8.5 or something. That's the one I'm talking about. Earthquake. Okay. And it's going to be, it's defined. This is really how it's defined. It's a log. And notice I'm not going to put any base. So it's log n base 10 of the ratio of the intensity of the earthquake felt. So that's different from the magnitude compared to the intensity of a reference earthquake. I'm going to ask, like, what kind of earthquake is it referenced to? And that's a good question. So this is the intensity of the earthquake. That's different from the magnitude. This is this guy. This is the reference intensity. And since that scale was created in 1935, it was actually the smallest possible earthquakes that were recorded. So the intensity of the smallest possible earthquake that was noticeable was the reference intensity. So those were the smallest recordable earthquakes in 1935. Okay. So in general, for magnitudes of earthquakes between 1 and 3, they're generally not felt. Okay. The highest the largest earthquake ever recorded had a magnitude of 8.6, and it was recorded in Chile in 1960. So yeah, I'll write that down because that's kind of important for what's coming up. So 1 to 3, so the magnitude generally not felt. Okay, 8.6 is the highest ever in Chile in 1960. Okay. Okay, so then let's try to understand how that scale works. Say you have an earthquake and it's 100,000 times stronger in intensity . Okay, then the reference earthquake, okay, smallest possible in 1935. Then what's going to be the magnitude of that earthquake? Let's see. The magnitude of that earthquake is going to be log of the intensity of our earthquake. Now it's 100,000 times more intense. So it's 100,000 times IN. Okay. So let's take a look at this. This is log of 100,000. You can remember the log. It's log in base 10. Right? When we don't write the base, it's in base 10. So here, what's that number? So we're trying to find what's the exponent, right? Logarithm is an exponent to which I raise 10 in order to get 100,000. And 100,000 is a power of 10. It's actually 10 to the 5. So our unknown logarithm is 5. So this is an earthquake of magnitude 5. So at 5, it's 100,000 times stronger in intensity than the smallest possible recordable earthquake in 1935. Okay. Now the last big earthquake in Quebec I was something like 13 when that happened. In the early 90s was I was in Quebec City. It was close to 6. Okay, so let's say it was 6. So the last big earthquake in Quebec, that's around 1990. Okay, maybe a bit after that, had a magnitude of 6. So what I'd like to know is how much stronger in intensity was it? No, actually, here's what I want to know. I would like to know the one, and that, so at 6 I could really feel it. Like the walls were shaking, like everything was shaking around me. I mean it impressed me very much at the time. Like living through an earthquake, we went under the door frame, and just in case the house would collapse, we didn't know what would happen. And I'd like to know, like those people in Chile in 1960 with an earthquake of 8.6, like how much stronger was it? Okay, so how much stronger was the earthquake in Chile? 8.6 in Chile. Okay, so that's what I'd like to know. So I'll just write here, this is the magnitude of the Quebec earthquake, okay? So it's calculated by looking at the log of the intensity of the Quebec earthquake over the intensity of the reference earthquake from 1935, the smallest possible recordable in 1935, remember? And I'll write M of C, that's the magnitude of so this is 6 here. And the magnitude of the Chile earthquake, that's log of the intensity of the Chile earthquake over IN. Okay? So, so I'd like to know how the intensities actually compare. So I want to know what is the intensity of maybe the Chile earthquake over the intensity of the Quebec earthquake. I'd like to know that. Okay, to say, well, it's like 1,000 times stronger, maybe, or maybe it's just 50 times stronger. I don't know. Okay, so let's try to calculate this. Okay, so one thing I'll do is I'll convert the two logarithmic equations into exponential equations. So let's take a look at the first one, this one. Okay. Now 6 is the log of IQ over IN. Now that means that 6 is the exponent to which I raise 10 in order to get the ratio of IQ over IN. And similarly, 8.6 is the exponent to which I raise 10 in order to get IC over IN. Okay, so that means what? That means that 10 to the 6 times IN is IQ, and means 10 to the 8.6 IN is IC. So you see where this is going, and now I can look at IC over IQ. I replace IC by 10 to the 8.6 IN and divide this by 10 to the 6 IN. So of course IN over IN simplifies to 1. So this is 10 to the 8.6 over 10 to the 6. And eventually this is 10 to the 8.6 minus 6. So it's 10 to the 2.6. And if you evaluate this, you are getting so 10 to the 2 is 100, 10 to the 3 is 1,000, so it's between 100 and 1,000. Turns out to be 398 times stronger. So that's what they felt in Chile, like something like 400 times more powerful than what I felt. So it must have been terrible. So maybe next time you hear on the news that there's an earthquake, think about me and logarithms. So there are exercises in the book, real life applications. One of them is actually related to the Richter scale, but you'll see examples where logarithms are actually used to measure stuff. We're going to see how they're used to do other stuff, especially since they're related to exponential functions. We can use those to perform calculations on the exponential equations. So, but that's it for that section.